Hello, good morning. This is Dr. K. Ramasamy, Professor and Dean Academics and Research from Electronics and Communication Engineering Department of KIT, Kalaignar Karunanidhi Institute of Technology, Coimbatore. I am going to deliver a short lecture on addressing modes in 8086 microprocessor, and this might be useful for third year Electronics and Communication Engineering, Computer Science and Engineering and Biomedical Engineering students. Okay, addressing modes in 8086. Actually, the need for addressing modes is that in order to perform an operation, we will be issuing an instruction to the machine, and when an instruction is being executed, the operand or data is needed, and there are different ways of providing the operand or data, and there are around 12 addressing modes possible in 8086 microprocessor. And the first category addressing mode, the first category is the addressing modes for accessing immediate and register data, and the second one is addressing modes for accessing data from memory, both direct and indirect modes. The third category is the addressing modes for accessing data from I/O ports, input-output ports. The fourth one is relative addressing mode, and the last one is implied addressing mode. So all the 12 addressing modes come under these five category. Now let's see the first mode of addressing, which is immediate addressing mode. Here the data or operand will be provided in the instruction itself. So there is no need to search for the data or operand neither from a register nor from a memory location. So this is the most efficient way of providing data to the processor. Say for example, providing, look at the first example, move CL, 03. CL means count register. 03 is the data. Here it is an 8-bit data. So what happens is 03, which is the 8-bit data, is moved to the count register, CL, count register low. And see the second example, move DX, 0525. Here the data is 16-bit data, 0525, and it is moved, copied to DX register, which is a 16-bit register, data register. And the second addressing mode is register addressing mode. Here the data will be available in any one of the registers, AX, BX, CX or DX and so on. So look at the first example, move DX, CX. Here CX is a count register, which is the source register, and DX is a data register, which is the destination register. So here the data from CX will be copied or moved to DX. Even after transferring data from CX to DX, the content of CX remains the same. It is only a copy instruction. And look at the second example, move CL, DL. Both are 8-bit registers. Data from DL will be transferred or copied to CL. And look at the third example, move BX, CH. Here it is illegal because the register size must be the same. That is CH illegal because is an 8-bit register, whereas BX is a 16-bit register. So there is a mismatch in register size. And the third addressing mode is direct addressing mode. Here the data will be available in memory. Please note that 8086 is a 16-bit processor, and it contains, it has 20-bit address lines, address bus, and so it will be able to address maximum of 2 to the power 20, 1 MB of physical memory. So the physical memory, 1 MB is memory, logically divided into number of segments, code segment, data segment, stack segment and extra segment, divided into number of, the size of each segment is 64K. So that is the thing. So here there is a need to convert address, 16-bit address into 20-bit physical address. Actually there will be two address components. One is the segment address, that is the base address, which will be available in any one of the segment register, code segment, data segment, stack segment or extra segment register. And another address component is the offset address or effective address, which will be available in instruction pointer. So both are 16-bit register, and there is a unit BIU, bus interface unit, where you will find an adder unit BIU. So the responsibility of this adder is the content of the segment register will be left shifted by 4 bits, and after that it will be added to the content of the instruction pointer, which is the offset address, to find out the 20-bit physical address. So this is the procedure to convert the 16-bit address into 20-bit physical address. Here direct addressing means the data will be available in memory. Direct addressing and the offset address or effective address in memory, the memory location, will be available in the instruction itself. That is why it's known as direct addressing mode. Look at an example. Move CX, start. Start means the effective address. CX, effective address or offset address. Its value may be 0040, and by default we will be referring to data segment. So the content of the data segment register, let it be 3050. So the bus interface unit or the adder available in the BIU will be left shifting this content of DS by 4 bits, and then it will be added with 0040 to find out the 20-bit physical address, which is 30540. So this is the 20-bit physical address. After calculating the physical address, it will access the 1 MB physical memory, and that content will be transferred to CL, and the content of the next immediate memory location, that is 30541, will be transferred to CH. So that is the meaning of this instruction or addressing mode. The fourth one is register indirect addressing mode. Here the difference is that in the previous one the offset address was available in the instruction itself directly. Here, instead of making it available directly in the instruction, it will be made available in any one of the registers. For example, it may be available in BX register or SI register or DI register. Indirectly, it will be available in any one of the registers. Okay, that's why it's known as indirect addressing mode. Look at this example. Move DI. DI is mentioned within parenthesis, comma BX. That means the data from BL will be transferred to a memory location whose physical address is equal to memory location. The content of the data segment register left shifted by 4 bits and added with the offset address, which is available in DI. Okay, so after finding out the physical address, the content of BL will be transferred to that memory location, and the content of BH will be transferred to the next immediate memory location. So this is the difference. Now the fifth one is based addressing mode. Here the effective address or the offset address, which is 16-bit, here will be available in any one of the base register. The base register, it may be either BX or BP. Base registers BX or BP. And apart from this, there may be an 8-bit or 16-bit displacement. Okay, so look at this example. Move AL, start of BX. It can also be mentioned like this: start plus BX. So here the effective address or 16-bit offset address is available in BX register, and the start offset address is may be an 8-bit displacement. So here how the physical address is calculated, which is equal to the content of the segment register, data segment register left shifted by 4 bits plus effective address, which is equal to the content of base register, that is the offset address, plus 8-bit or 16-bit displacement, which is mentioned as start. So here please note that the effective address is available in any one of the base registers, BX or BP. That is why it's known as based addressing mode. If it is available in an index register, either SI or DI, it is known as index addressing. See, here the effective address or offset address will be available either in source index register or destination index register. Apart from that, there may be a displacement component which may be either 8-bit or 16-bit displacement. Look at this example: 8-bit or move BH, start of SI. So SI will be holding the 16-bit offset address, and start denotes the 8-bit or 16-bit displacement. So both will be added, and then it will be added with the content of data segment register left shifted by 4 bits in order to find out the 20-bit physical address. Now the seventh one is a mix of the above two based indexed addressing mode. So here the offset address will be available in both base register and index register. Is a combination of the above two. Look at the example, move alpha of SI BX comma CL. So that means the content of count register, which is an 8-bit data, will be transferred to a memory location whose physical address is equal to the sum of location whose physical data segment register left shifted by 4 bits plus the content of a base register plus the content of an index register plus the 8-bit displacement mentioned as alpha. So it's a combination of about two. And the eighth one is a string addressing mode, using which we can transfer a number of string bytes or string words from one part of the memory to another part, either from lower part of the memory to upper part of the memory or vice versa. So here by default the segments involved are data segment and extra segment. So you will be able to move data between these two segments, and from where you are moving string bytes to where you are moving. So the source address will be available in SI register, source index register, and the destination address will be available in DI, destination register. And the direction of data transfer, string bytes, string words data transfer will be indicated by the status of the direction flag DF. If DF is 0, then you will be able to transfer string bytes from lower part of the memory to upper part. If DF is set, if it is 1, you will be able to move data from higher address to the lower address. And for after every transfer of string byte, you will be incrementing, the system will be incrementing the content of SI and DI by 1 if it is a string bytes transfer, or by 2 SI and DI if it is a string word transfer. Okay, so if you are transferring string bytes or words from upper to lower, then you need to set this DF. In that case, SI and DI will be decremented by 1 or 2 depending on you transfer byte or word. And the ninth one is IO mode, which can be either direct mode or indirect mode, input output mode. So for example, look at this example, out 05 comma AL. For example, that means you are sending data from processor AL, that is accumulator register, which is an 8-bit register, to an output device whose address is mentioned directly in the instruction. That is why direct IO. The address is mentioned directly in the address, which is 05. So the address of the output device receiving data from processor, which is 0, that is AL register, is whose address is 05. And if the address of the input output device is mentioned indirectly in a register, it is IO mode, indirect mode. For example, look at this example, instruction IN in AL comma DX. Here data is being received from an input device whose address is in DX register. So the address is not mentioned directly, as in this case it is available in DX register. That is why mentioned directly. This is IO mode, indirect. And the last but one is the relative addressing mode. So here the address will be related to the current content of the program counter. For example, look at this mnemonic, JNC start, jump on no carry. Look, if there is no carry, if carry flag is 0, then you need to jump to a memory location, an address to whose physical address is equal to the content of the data segment register left shifted by 4 bits plus the 16-bit offset address, which is mentioned in the instruction as start. So the jump location or target location is related to the current content of the program counter. That is why it is relative addressing mode. And the last one is implied addressing mode. Here neither the data, the last one is nor the address will be specified. By implicit, you will be able to know what operation the machine will be performing. You will be able to find only the mnemonic neither data nor address. For example, look at this mnemonic or instruction CLC, that means clear carry. You never find data or the address here. So it is implicitly specified that you are clearing the content of the carry register. And another example is STD, set direction carry register. Set carry STC. So these are the few examples for implied addressing mode. So these are the various possible addressing modes in 8086 processor. I hope this is useful for the third year ECE, biomedical and computer science engineering students. Thank you so much.